Hello students, in this video I'm going to go through 4 exercises which are going to be really similar to the assignment that's associated with the lesson. Alright, so let's take a look at this right here. The task says to evaluate f of a at a is equal to -2. Okay, so what we're going to do, okay, instead of evaluating this by replacing a with -2, we are going to try and apply synthetic division, right, or synthetic substitution. So f of -2, if I go through this, okay, this is going to equal to the remainder. So if that's the case, then all I got to do is do 6, 9, -4, and 16, right? So this is 6. -12 plus 9 is -3. -2 times 3 is 6. -4 times 6 is positive 2. 2 times -2 is -4. So I get 12 as a result. So this will equal to 12. Of course, you can also, directly substitute it in. Let's say if you forget synthetic substitution, would it be any faster or slower? It may be a little slower just because, this does require a little bit of mental math and some computation, right? So actually, I'll just do it really quickly to do it side by side as a comparison here. So if I take a look at this, right, -2 to the third, that's -8, so 6 times -8. -2 squared is 4, so it's 9 times 4. 4 times -2 is -8, so then it becomes +8 plus 16. So I get -48 plus 36 plus 8 plus 16. And if I try to combine like terms here, actually all these are like terms. So -48 plus 36 and 8 makes 44 plus 16. -48 plus 44, so that's -4. Plus 16 is positive 12. So I don't know which one's easier. You be the judge, right? So sometimes synthetic substitution can be a little easier. Let's take a look at another one. All right, m is equal to 2. So again, I can go through just directly substituting, or I can apply synthetic substitution. And if I do, I get 1, -1, 3, -8, -4. So if I go through this, this is 1, and then 2. -1 and 2 makes 1. 2 times 1 is 2. 3 plus 2 is 5. 2 times 5 is 10. -8 plus 10 is 2. 2 and 2 makes 4, and I get 0. So this turns out to be 0. And as a result, this is actually also a factor, right? So m minus 2 is a factor of f of m. All right, so let's do it side by side. Let's do a comparison here. So let's say f of 2 is equal to 2 to the fourth minus 2 to the third plus 3 times 2 to the second minus 8 times 2 minus 4. All right, 2 to the fourth, that's 16. 2 to the third is 8. 3 times 2 to the second, that's 12, minus 16, minus 4. 16 minus 8 is 8, plus 12. -16 minus 4 is -20. 8 plus 12 minus 20 is indeed 0. Again, you be the judge. I don't know. Sometimes synthetic substitution, can be really fast. Sometimes, depending on the situation there, directly substituting in values into the function can be just as fast too. All right. Determine if the binomial is a factor. So if this is indeed a factor, right, then what will happen is I will end up with a remainder that is 0. Or in other words, if I take if I take negative 5 and I directly substitute it into the numerator, let's call the numerator f of n because it's in terms of n. If f of negative 5 turns out to be 0, then yes, it will be n plus 5 will be a factor. So let's quickly figure out what this is, okay, whether or not this is a factor or not. So rather than, because I don't want to deal with really large number and the numbers can get really large really fast, so I'm just going to write out negative 5, 3, 15, negative 2, negative 4. And let's see here. So I have 3. Negative 5 times 3 is negative 15. Add them, I get 0. Negative 5 times 0 is 0. Negative 2 plus 0 is negative 2. Negative 5 times negative 2 is positive 10. Negative 4 plus 10 is positive 6. So I have a remainder of 6. So will n plus 5 be a factor? It will not be a factor. Okay, let's try another one. I have x to the third minus 11x squared plus 25x plus 29 divided by x minus 5 in this case. Again, if I go through using synthetic substitution, I can then easily figure out what that is, right? Or alternatively, I can just substitute it into the graphing calculator and evaluate it, depending on the situation here. All right, so look, let's take a look. If I substitute in, let's call the numerator f, right? So f of 5. If this equals to 0, then x minus 5 will be a factor. Let's see if this is really indeed the case or not. So if I do this, I end up with 5, and I have 1, negative 11, 25, and 29. Let's substitute it in. So I get 1. 5 times 1 is 5. Negative 11 plus 5 is negative 6. 5 times negative 6 is negative 30. 25 plus negative 30 is negative 5. 5 times negative 5 is negative 25. And this would be positive 4. So again, this is not a factor. Let's do one more where it potentially is a factor, because I didn't realize that both of them turn out to be not factors. Let me see here. Let's do question 16. Okay, well, let's see if this is indeed a factor or not. So actually, this was simple enough where I can just directly substitute in. So let's do that. F of, let's say, negative 2. Okay, this is 4 times negative 2 cubed plus 5 times negative 2 squared minus 6 times negative 2. Negative 2 cubed, that's negative 8. So this is 4 times negative 8. Negative 2 squared is 4, so 5 times 4 is 20. 6 times negative 2 is negative 12, so it's plus 12 because minus negative. And I end up with negative 32 plus 32, and this does indeed equal to 0. So therefore, x plus 2 here, x plus 2 is a factor, because f of negative 2 is equal to 0.